Hey everybody, how's it going? It feels like forever since I've made one of these videos, and I'm so happy to be able to get back on the horse and do it again. And this is for a good topic too. Today what we're going to be talking about is adding and subtracting fractions. I know you've all been waiting for it. But today what we're going to focus on is just adding and subtracting fractions with like denominators, or the same denominator. So, let me ask you a question. What do you think happens when you have to add two fractions with the same denominator? Let me tell you. What you do is you keep the denominator the same. That denominator stays the same, and you just add the numerators. So if we look here, I have 1/8 plus 2/8. That equals 3/8 because I'm keeping my denominator the same. It's staying 8, and I'm just adding my numerators. 1 plus 2 equals 3. Denominator stays the same the whole time, no matter what we're doing. As long as we're adding and subtracting with a like denominator, it stays the same. And if you look here, it's the same with subtraction. 3/5 minus 2/5 equals 1/5. I didn't subtract my 5s. My 5s stayed the same. All I did was subtract 3 minus 2, and I got 1. Okay? Let's try a little bit of it. Remember, denominator stays the same, but you have to write your fractions. You have to write your sum or difference in simplest form. So 3/8 plus 1/8, that would be, my 8s stays the same, my denominator stays the same. 3 plus 1 is 4. But I'm not done. I need to write my answer in simplest form. I can divide both of these by 4. My numerator divide by 4, denominator divide by 4, and I get 1/2. And the same thing with 6/7 minus 3/7. Denominator is 7 because it stays the same. 6 minus 3 is 3. Am I done? Yes. That is in simplest form. So we are good there. And 1/2 is my answer there. All right. Do the next two. Remember the order of operations. We do what's in parentheses first, and then we do what's outside of parentheses. Try these next two. Pause the video, do your work, and press play when you have your answer to check. 3, 2, 1. Pause. All right. How'd you do? For our first one, we do our subtraction first. 5/8 minus 3/8 is 2/8. 1/8 plus 2/8 is 3/8, and now we're done there. That's in simplest form. For the next one, I still do my subtraction first because it's in parentheses. 7/10 minus 3/10 is 4/10, plus the 1/10 outside gives me 5/10, but 5/10 isn't in simplest form. I can divide top and bottom by 5, and I would get 1/2 as my answer. All right? But now, here's where things might start to get tricky. Because sometimes we have to regroup. And it's not like regrouping in subtraction. It's a little bit different than that. Let me show you what I mean. So if I have an addition problem, 6/12 plus 3/12 plus 5/12. 6/12 plus 3/12 equals 9/12 plus 5/12. And that would be 14/12. Remember this for the rest of your life. You cannot leave an answer to any problem as an improper fraction. We cannot have 14/12. We have to regroup that. And in this case, regrouping just means changing it into a mixed number. 12 goes into 14 one time. There are 2 left over. 12 stays the same. My denominator stays the same. But we're still not done. Still we're not done. Because 1 2/12 is not in simplest form. I can divide. I'm going to keep my 1 because my whole number stays the same. I'm not touching that. But I could divide my numerator and denominator by 2. And I would get 1 and 1/6 as my final answer. Do the next two. 12/20 plus 5/20 plus 7/20 and 6/7 plus 3/7. Do the work. Pause the video. Come back to find out if your answers are correct. 3, 2, 1, pause. All right, and there we have it. For our first one, let me just circle that real quick. For our first one, we add up 12 20ths, 5 20ths, and 7 20ths, and we get 24 20ths. We need to regroup. In other words, just make it into a mixed number. And we get 1 and 4 20ths, but that's not it because we need our answer in simplest form. Divide numerator and denominator by 4, and you would get 1 and 1/5. And that is it. That is in simplest form. And for our last one, 6 sevenths plus 3 sevenths, we get 9 sevenths because we keep our denominators the same. Just add our numerators, 6 plus 3 equals 9. We need to regroup that, make it into a mixed number, 1 and 2 sevenths. All right, rolling right along. We can also have word problems. Let me just change my view here real quick. We can also have word problems for adding and subtracting fractions like denominators. Like this one, if Emma and John ride 2 roller coasters in the morning and 5 in the afternoon, what fraction of the park's roller coasters will they ride? Here, you might be a little confused because they don't tell you how many roller coasters in the problem. But look right here. How many roller coasters are there? 8. You count these up, 1, 2, 3, 4, 5, 6, 7, 8. That's how many roller coasters there are. So if they ride 2 in the morning and 5 in the afternoon, we're adding, our denominator is 8. Because that's how many roller coasters there are. There are 8 roller coasters in the park. And what fraction of the park's roller coasters will they ride? Ooh. Our denominator stays the same. We add our numerators, they would have ridden 7/8 of the park's roller coasters. And here, this is a great adding and subtracting fractions problem because we're going to see a lot of recipe problems. Sam and Justin want to bake a cake for the school bake sale. The cake recipe calls for 1/10 teaspoon. 1 second. Sorry, everyone. Urgent phone call from the president. But that can wait. Back to adding and subtracting fractions. We're going to see a lot of recipe problems. And here, Sam and Justin want to bake a cake for the school bake sale. The cake recipe calls for 1/10 a teaspoon of sugar, 2/10 a teaspoon of flour, and 6/10 of a teaspoon of vanilla. How much total sugar, flour, and vanilla does Sam and Justin need to bake the cake? What do we have to do? Of course, we have to add 1/10 plus 2/10 plus 6/10 equals, adding up my numerators because my denominator stays the same. 1 plus 2 is 3, plus 6 is 9. And is that in simplest form? You bet your bottom dollar it is 9/10 of a teaspoon in total. All right, we have 2 more problems here. Solve both of these problems. Make sure your answers are regrouped if they need to be, in simplest form if they need to be. Pause the video, do your work, come back with answers. 3, 2, 1, pause. And there we have it. For the first one, 2/3 plus 2/3 equals 4/3. And we need to regroup, make it into a mixed number, 1 and 1/3. Second one, John ate 3/8. Andrew and Jake both ate 2/8. Make sure you have 2 2/8 in your equation. 2/8 plus 2/8 is 4/8 plus 3/8 is 7/8 of the pizza. And that's in simplest form. All right, my video people, turn your notes to the next page. And there's nothing there. I want to show you something really quickly that you're going to see on your practices. So, let me just show you. Put a number 1 on the back of that page. So, we've only worked with fractions so far, adding fractions with the same denominator. But we can also add mixed numbers with the same denominator as well. So let me show you an example of that. If I have 2 and 3/8 plus 1 and 1/8, what I would do is exactly what I would do with the normal just fractions. I would keep my denominators the same. Denominator is always going to be 8, and add my numerators. 3 plus 1 equals 4. And then what I would do is I would just add my whole numbers. 2 plus 1, 3. Okay? But I'm not done here yet, because 4/8 we can divide by 4, top and bottom, be 3 and 1. Okay. And the same goes for subtraction. If I had a subtraction problem with mixed numbers, 4 and 5 sixths minus 2 and 4 sixths, I would subtract my whole numbers. 4 minus 2 is 2. Then subtract my fractions. My denominator stays the same. 5 minus 4 is 1. Okay. Same thing with mixed numbers. You add and subtract your fractions the same way. And then you just need to add or subtract your whole numbers. It's not going to get too much crazier than that. All right? If you still have questions about adding and subtracting fractions with like denominators, sorry, I'm getting ahead of myself, please come up and see me, join my mini lesson, find me, flag me down. If you do not have questions, and you are good, you've understood everything, go on and start your practices. All right? Great job today, everybody. 3. This is Mr. Tennell. I don't know why I started counting. This is just Mr. Tennell signing off until next time. Bye, everybody. See you later.